Okay, so for number one, explain to yourself with your own words what are the key takeaways from the video. So the video basically talks about determining a system's stability, whether it be stable or unstable. So the speaker defines a stable system as a system wherein after a disturbance, it would then go back to its equilibrium state. So take for example a marble. When we put it inside a bowl and move it, it would still go back to its original or equilibrium state, hence making it stable. And contrary to this, for instance, when we flip the bowl, put the marble on top, and move the marble, it would then never go back to its equilibrium state, hence making it unstable. So with that, there are like several metrics he discusses as to how we can determine a system stability. So first, he talks about the Bibo stability, wherein a bounded input, which can be an input with limits, then proceeds to a bounded output, then this would be a stable system. And contrary to this, a bounded input to unbounded output would then be unstable, meaning the unbounded output would have a value such as, for say, infinity or exceed the limit. And moving on, he also discusses the equation n of s over d of s, wherein for n of s represents the number of zeros for which n of s would be 0, and for d of s represents the number of poles for which d of s would be 0. And this equation can also be represented through a graph, wherein the graph would have a real part and imaginary part, and we would take into account the characteristics of each quadrant to determine whether the system would be stable or unstable. And lastly, he also introduces the Routh-Hurwitz criterion. For number two, was the video helpful in giving you more understanding of the subject? Yes, it was definitely helpful in introducing to me what a stable system truly is. However, I guess I'm still quite confused how we could apply controls, but I guess this could be discussed probably later on. And as a future engineer, what are some interesting insights you gained from the topic? To me, the most interesting one was probably how we can formulate an equation to determine the stability of a system. So it's really interesting how although people would probably like see the state of being stable or state of being unstable through a simulation or a demonstration such as the marble, it's really interesting to know that aside from this, we can create conclusions based on formulas such as the n of s or d of s and so on.